Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your channel Chandan Physics. In this video, we are going to discuss reciprocal lattice. Let's begin. We have already discussed about space lattice. So, why it's necessary to introduce reciprocal lattice? Let we take space lattices in two dimensions. The array of points in space having equal surroundings is the space lattice. In a particular crystal, the space lattices are arranged in any ways. But when these space lattices are arranged in parallel way, that represents the parallel planes, and each parallel plane has represented by the same Miller indices. If I take that parallel plane having the Miller indices S, K, L, that is also the parallel plane. The set of parallel planes having the same Miller indices S, K, L, and the distance in between these two parallel planes is known as the interplanar distance, and it is represented by dSKL. D of SKL, that is the interplanar distance. Interplanar distance between two parallel planes having the same set of parallel planes, and that parallel plane or that set of parallel planes are represented by the Miller indices SKL, that is the Miller indices. With the help of Miller indices, we can easily explain the set of parallel planes. So, what is reciprocal lattice? Reciprocal lattice is that lattice point. Instead of that parallel planes, we can use just a point. So, reciprocal lattice is an infinite periodic three-dimensional array of points whose spacing are inversely proportional to the distances between the planes in the direct lattice. So, instead of these parallel planes, we can just use a point, a lattice, and the arrangement of these lattices are known as reciprocal lattice. So, reciprocal lattice is an infinite periodic three-dimensional array of points whose spacings are inversely proportional to the distance between the planes in direct lattices. So, how we construct the reciprocal lattices? There are some methods we have to follow to construct a reciprocal lattice. The methods are as: take any point as an origin in direct lattice. Let me take a direct lattice crystal lattice the lattices at corners we have to take any point which prefer as origin in that of direct lattice. Let I take a point here. That origin point is chosen arbitrarily. From this origin, draw the normal to every set of planes in the direct lattice. There are a huge number of planes. From that of origin, we draw the perpendicular to this plane, that plane, that plane, that plane. Also, if we have taken any kind of plane in between these two, we can draw the normal. But what be the length of that of drawn normal? That set length of every normal drawn equal to the reciprocal the interplanar spacing, that is 1 divided by d skl. D skl is the set of parallel planes having the Miller indices skl. If a set of parallel planes having the Miller indices skl, Miller indices as let 10 centimeter. So, its reciprocal 1 by 10 is equal to 0.1. From that point, we draw the normal to this plane, that length is 1 divided by d of skl, and finally we place a point at that of each normal end. Similarly, that normals are drawn, and finally the arrangements of these points, are nothing but the lattice points. In this way we construct, that points are the reciprocal lattices. These are the direct lattices, that are the reciprocal lattices. By using the reciprocal lattices, reciprocal lattices are useful to us to know the properties of the crystal plane, slope of the planes, and what be the interplanar spacing, these two properties of a crystal plane can be easily explained. This kind of properties of crystal plane is easily explained by using this. So reciprocal lattice is useful for slope of the planes and interplanar spacing calculations. And we construct the reciprocal lattices by using these methods. Now, what will be the mathematical way to point out these reciprocal lattices? In case of direct lattices, a translational lattice vector is used, having the lattice vectors a vector, b vector and c vector. Mathematically, in direct lattices, the basis vectors are a vector, b vector and c vector, whereas in reciprocal lattices the basis vectors are capital A vector, capital B vector and capital C vector. In case of direct lattices, these three are the basis vectors. In case of reciprocal lattices, that three are the basis vectors. So, what will be the relation in between the basis vectors of direct lattices and reciprocal lattices? To show the relations in between these two, we have to idealize the vector algebra property in between these two basis vectors. By using vector algebra, so a vector, that is the basis vector, dot product with reciprocal lattice vector capital A vector, that results 1. Similarly, a vector with that of b vector results 1 and a vector dot product with c vector result 1. Another set, when b vector is dot product with a vector results 0, b vector dot product with b vector results 0. And b vector dot product with c vector, it results 0. Another set, as c vector dot product with a vector, one a dot c or c dot a, nothing will be changed. C vector dot b vector, sorry, c vector dot a vector results 1, c vector dot b vector results 0, c vector dot c vector results 0. These are some basic vector algebra we use in between the basis vectors and reciprocal lattice basis vectors. This basic vector algebra is useful to us as b vector dot product of a vector is equal to 0 and c vector dot product of a vector is equal to 0. It is 0, c vector dot 0, b dot a 0, c dot a 0. Dot product of two vectors is equal to 0, then the angle between these two are 90 degree, which implies a vector is perpendicular to b vector, and again here a vector is perpendicular to c vector. Thus we can say that a vector is perpendicular to the vector product of b vector and c vector, vector product or cross product of small b and c vector, that is a vector is directly proportional, sorry, not perpendicular, that a vector is parallel. Since these are results are 0, this vector is parallel. As parallel, so a vector is directly proportional to b vector cross c vector, parallel to that of vector product b and c. Therefore a vector is equal to k times of b vector cross c vector. That is a relation. As you know, also you know a dot a is equal to 1, or a, in place of a vector we use that one as k times of b vector cross c vector is equal to 1. From that relation, k is equal to 1 divided by a vector dot b cross c. Therefore a is written as, therefore a vector is written as, in place of k we substitute that value. First of all, k into b cross c is equal to, in place of k, that is 1 divided by a dot b cross c into b cross c. Or we write a vector is equal to b cross c divided by a dot b cross c. Similarly, for B vector, it is C cross A divided by B dot C cross A, and C vector is equal to A cross B divided by C dot A cross B. But our simplicity, on the right hand side we just introduce a 2 pi. For our simplicity, we multiply the right hand side by 2 pi, so that we have A vector is equal to 2 pi times B cross C divided by A dot B cross C, and B vector is equal to 2 pi times C cross A divided by B dot C cross A, C vector is equal to 2 pi A cross B divided by C dot A cross B. Here A vector, B vector and C vector are called reciprocal primitive lattice vectors. Reciprocal primitive lattice vectors. So here every crystal, therefore every crystal has two lattices, one as crystal lattice, another one as reciprocal lattice. So when we rotate the crystal, both the lattices are rotated. So in order to explain the reciprocal lattices, we can represent it by the vectors A vector, B vector and C vector. With the help of this video lecture, we understand reciprocal lattice, definition of reciprocal lattice, in which way we use that reciprocal lattice, construction of reciprocal lattice. Mathematically, we show the reciprocal lattice. So here, with this useful and informative notes, let me wind up this session. Thank you.